Hi friends, I am Krishna Mohan. Okay, today we are going to learn about what is boundary value analysis, or which is short form. We will be calling it as BVA. Okay, this is very important topic with respect to interview point of view. Okay, let's go. This boundary value analysis is the extension. Actually, this is an extension for the equivalence class partitioning. Okay, this is one of the means design techniques, means black box design techniques. Okay, this technique is used to minimize the number of test cases. Okay, uh, and we are using this boundary value analysis when there is a range kind of input. Suppose there is a age field and age field, and that age will be taking from 18 to 60 years. Okay, means that will be the valid range. Okay, if that kind of means customer has given that, okay, that age field should accept only the age from 18 years to 60 years, then in that situation we have to use this boundary value analysis. Okay, uh, in equivalence class partitioning, we have already learned that first we have to partition in equal means classes or equal partitioning. Okay, so it is the extension for ECP. So first, then is there any other scenarios where we can use this boundary value analysis? If you ask, no, only the range. If the range is given, then only we will use this boundary value analysis. Okay, I have given one example of the age. Okay, there may be a number of examples. Suppose there is a text area where it has told that, okay, it should accept from 20 to 1000 characters. Okay, so there is also a range is there. Suppose name field is there. Okay, it should accept minimum 3 to suppose uh, obviously 100 characters maybe. Okay, otherwise the username field is there. Okay, there are some restrictions. Okay, whenever there is a restriction, whenever there is a minimum and maximum value is given, there we have to use this boundary value analysis. So that is what is the analyzing the boundaries. Then what is the boundary? The minimum value and the maximum value are the boundaries. Okay, we'll see what is the definition and all. Okay, okay, see, whenever one needs to develop the test cases for the for a range kind of input, then it is suggested to use a technique called BVA or boundary value analysis. Okay, uh, okay. According to BVA, instead of testing for the whole range, just okay, concentrate on its boundaries. So suppose if I take the example of the age, if age field has to accept the age from 18 to 60, in that case, how many test cases you can write? Okay, how many positive test case you can write, how can negative test case you can write. Okay, we can write positive, how many we can enter 18 and we can check, we can enter 19 and we can check, so on up to 60 you can enter and you can check, means how many test cases you will be having to calculate it. Okay, how many test cases you have to write. Okay, so that is about positive. Then what about the negative test cases? Again, means see, for less than 18 means minimum 17 test cases you have to write for less than 18, and after above 80, if you consider suppose sorry, above 60, if you consider 100 is the maximum age, suppose. Okay, if you want to calculate, means you have to find the you have to write the test cases, you have to want to test up to 100, so that will be 40, and it will these are from 17. How many you got? 57 you got. So 57 negative test cases and these many positive test cases. So uh, to avoid all those things, to avoid writing of many test cases. And test coverage is also should be, you have to concentrate on the test coverage, and we have to minimize the number of test cases. Okay, to minimize the number of test cases, what we have to do? Okay, we have to use this technique called boundary value analysis. Okay, so how many test cases you have to write? Okay, if there is a range kind of thing. Okay, we will see. Okay, when you consider, okay, uh, BVA, known as the range checking. Okay, it is also known as the range checking, and can be applied at any level of testing. Means in unit testing you can do, in integration testing you can do, in system testing or user acceptance testing. Okay, whatever the level it is. Okay, this is a technique of black box testing. So wherever you are checking it, any range, we can use this boundary value analysis. Okay. Okay, then what we have to do first? First, if you want to take the range, then there will be the maximum number and there will be a minimum number. That is what is the range. If 18 and 60 is the range, 18 is the minimum value, 60 is the maximum value. Okay. First, what you have to do is, as you have done in ECP, first we have to divide it into partitions. Partitions which contain the data. If you use that data, it has to give the same result. Suppose means we have to arrange, we have to means take the data in such a way that if you arrange the means if you partition in such a way that each partition means class. Okay, each class of data should exhibit the same result, should get the same result. If you take any input data from any class, that should give same result. Okay, so we have to first divide, like in ECP we have to divide into equal partitions. Okay, so less than 18 is one partition. Okay, 18 to 60 is one partition, then above 60 is another partition. Okay, where minimum is 18, maximum is 60. Okay, so if you take any value in this partition, we got how many partitions? Three partitions, means we got three classes. Okay, if you take any value from these three classes, suppose if I am taking any value from the class less than 18, then it will exhibit the same result. Means if I am entering the age less than 18, suppose if I entered 10, then it will give some sort of error message, because it should not take, no. In the same way, if I take any value above 60, so suppose I am taking 70, then same way I will get the error message. I say take 70 or 80, okay, 75, whatever value in that particular class, in that particular partition, I am getting the error message. So we have to first arrange the partitions in such a way that the data inside that partition should exhibit if I am entering the any data in that particular class or a partition, that will give the same result, same output. Okay, that's what is the ECP. In ECP we have learned. Okay, that's what you have learned, no. And we have to take one value from each one. Okay, so here in BVA, boundary value analysis, we will be not taking any value from the partition, but we have to concentrate on the boundaries, because in coding, there is a chance that the error will be occurring at the boundary. Suppose if they are writing any code, if they have to write less than or equal to, but they forgot equal to. Okay, then the error may occur. Okay, so because there is a condition checking over there, so that is what is the reason where there is a probability of getting the error at the boundaries is maximum. Okay, so here what are the boundaries? Okay, we'll check what are the boundaries over here. Boundaries are, if you take the example of the 18 and the 60, 18 will be the minimum value and 60 will be the maximum value. These are the boundaries. Okay, so we have to take the values nearer to the boundaries. Okay, so okay, behavior at edges of each equivalence partition is more likely to be incorrect than the behavior within the partition. Okay, so that's what I am saying. Okay, so there is a chance of getting the error at the boundaries is more than if you take any value from the class. Okay, any value. Suppose if less than if I am saying that there is one partition, there is three partitions. Okay, less than 18 is one partition, 18 to 60 is one partition, above 60 is another partition. So if you take any value above 60, if you take 70, then the chance of getting the error is less. If I take nearer to the boundary, that is means 61, if I take, the chance of getting the error is more. Or if I take uh, positive side, if I take 59, there is also a chance of getting the error is more. So instead of taking any value from the partition, here in boundary value analysis we will be taking the values nearer to the boundaries. Okay, so as per BVA, the range can be taken as, see here first, what is the minimum value? 18, maximum will be 60. Okay, in my example. Okay, so you will be taking nearer to the boundaries. So minimum minus 1, minimum, minimum plus 1, then maximum minus 1, maximum, maximum plus 1. Okay, so how many test cases you have to write? We have to write 6 test cases. Okay, you understood, I think. Okay, we'll see with an example over here. See here, if I'm taking the 18 as the minimum value and 60 as the maximum value, see I have written in green, so they are the positive. Okay, positive data means valid data, and minimum plus 1 will be how much? If 18 is the minimum value, minimum plus 1 is the 19, so it is also a positive, means it is also a positive data, that is the valid data. So maximum is 60, then what will be the maximum minus 1? 59. So if you enter 59 also, it will not give any error message, it will take it. So this is also positive. So how many? This is the valid data and this is the invalid data. Okay, previously in ECP we used to take any value from the invalid or any value from the valid. Okay, so instead of taking any value, we are taking the values nearer to the boundaries. Okay, nearer to the minimum and nearer to the maximum. Okay, so how many test cases we will be getting? We will be getting 6 test cases: minimum minus 1, minimum, minimum plus 1, maximum minus 1, maximum, maximum plus 1. Where 4 test cases are positive test cases and 2 test cases are negative test cases. Means negative test cases, we will give the invalid input so that we get the some error message also. Okay, next we'll check with an example over here. See here, the same example. Suppose that there is a text box which will accept okay, here is the alphabets from 18 to 60. Okay, suppose that there is an alphabet which is actually number of, means alphabets. Okay, here number of alphabets is 16 to 18. Okay, then we have to test the text box by giving the values. Okay, um, 17, 18, 15, 19. That's what it is. First, minimum is 18, maximum is 60. Okay, minimum minus 1, 17, minimum plus 1, 19, maximum minus 1, 59, maximum plus 1, 61. So here how many test cases? We have to write 6 test cases, 4 for valid and 2 for invalid. Okay, so here wherever there is a range kind of inputs, okay, there we have to use the boundary value analysis. Okay, okay, even though we can use ECP also, but it is more appropriate if you can use boundary value analysis. Okay, I hope you understood what is boundary value analysis. Here I have given the example. Okay, that same example. Okay, this is the range. This is minimum minus one, minimum plus one, maximum minus one, maximum plus one. See here, negative test case, positive. There are four positive test cases and two negative test cases. Okay, that's what is how we are going to cover the entire test case. Means instead of doing the exhaustive testing of that particular field, we are minimizing the test cases. Okay, instead of writing 100 to 100 test cases, we are writing only 6 test cases. It is enough. Okay, so I hope you understood this one. Okay, thank you.